Hello, everybody. Welcome to the other side of the classroom. I'm Akanksha, and this is my project walkthrough for the game that I'm making called UnderSouled. And this is actually inspired by two of my favorite games, which are Overcooked and Dark Souls. So I wanted to have a mix of both these worlds, sort of have that chaotic feeling from Overcooked and have those eerie vibes from Dark Souls setting. And that's what I tried to achieve here. My game will have certain features like new materials, player input, some kind of camera manipulation, a few object interactions that I'm hoping will be approved as sort of like trigger objects, and some animations and some other things as well that I'll be showing you along the way throughout this video. Now, before we go into the video and talk about the project itself, I want to give a full disclaimer about all the help that I've used for building this project so far. And I've listed all of that here in my README file. So I have used a lot of assets from the Unity Asset Store to build my game environment and make use of all the objects that I got from there. So these include a lot of materials, textures, and models that help me sort of like enhance the visual quality of the game. And these are mostly the assets that I've used from Unity Asset Store. They looked really good, and there's no way that I could have recreated that on my own. So I just made sure that I use the assets, good looking assets that I could find on that store, and I'm trying to attribute that here. Apart from that, I took a lot of help from different YouTube tutorials. Mainly, I took help from this game called Kitchen Chaos by Code Monkey and RPG Hero Diner by Design and Deploy. I wanted to learn about good coding practices and also wanted to understand what people do in order to make a game of this scale. So I tried to follow sort of like a same structure that they followed when they were creating their kitchen game, and also took a lot of scripts that they had and sort of like tried to deploy that in my own game environment. Apart from that, I also learned a few complicated things that I did not know about before. So I have listed the videos that I've taken help for those as well. And of course, apart from all of these things, I had long conversations with ChatGPT, and that's why, and so a lot of credit goes to ChatGPT as well. I just want to make it really clear that I won't have been able to write most of the scripts that I have added in my gameplay without the help from these resources, YouTube videos, or ChatGPT. And I just learned a lot in the process, for sure. So overall, you could say this project is a combination of all the help that I've taken, whatever I've learned in the class so far, and I've added my own implementation over that. Cool. So now that we have that covered, we can move on to a quick game demo. All right. This is what my game looks like so far. Let me go in full screen. Let me hit play. Okay, so this is my kitchen that's inspired by a dungeon setting, and you can see a forest outside of it as well, sort of something like you'll see in Dark Souls. And there's like a monster moving around outside, and then there's also a bat somewhere flying around. We can come back to that. But yeah, overall, the main game will take place inside of this kitchen. This is my player, which is like a ghost, and I just thought it would be fun to have like a ghost chef, which is sort of like undersold and not able to serve to all of these monsters outside. But yeah, the ghost can move around in the kitchen. It can move towards the direction it's facing, and it can also interact with different these table counters that you see on the side. So if I go near any of these table counters, let's say this one, you can see that the table sort of gets highlighted. I'm not sure if you can see the color difference in the video as clearly, but there's definitely a subtle change. Yeah, maybe I think it's a bit clearer here. Yeah, So I can interact with all of these different table counters, and so these are, for example, since I'm in a kitchen, I need to pick up certain food items. So these tables are for me to pick up food items, and I can. So this table has bread loaf. I can interact with this. Let me press the key E, and then I got a bread loaf from that table, and I can put it over any of the table which is empty. So if I interact with this table again, I can keep it here, and then I can sort of like do that with all the different food item tables that I have here. So I took it from one counter, I placed it here, and let me take a meat patty, let me keep it here. Yep. And then if you see, if I, let's say if I pick something up, and if I try to pick something up again, I can't. Even though I'm pressing the key E, I'm not really picking anything else. And if I try to keep this cheese here, I can't do that because there's an object on that table again already. So I have to find an empty table container or like empty table so that I can keep it there. Yep, that's mostly it. It kind of sounds less, but then it took me a lot of time to actually be able to achieve this. The overall goal of this project is basically for me to develop this into a full-fledged overcooked cooking level. So my player in the next creative project too would be able to pick up these food items, take it to counters that have these chopping boards, cut them and prepare them, cook them, sort of like prepare like a meal, and actually serve these monsters. So yeah, so these are mostly it. I have these monsters walking around the forest here. Oh, I think we can see the bat here on the side as well. So yeah, they're sort of like patrolling this kitchen, and maybe I'll add a few more monsters later on. But overall, that's it. There's a lot of small details that I've added in this game. I can walk you through that separately. But yeah, there's like a few animations. If you can see, my ghost is moving up and down when it's standing still, and on also like walking. Certain animations attached with that mummy monster that you see on the side, and then there's an animation attached to that bat as well. But yeah, this is mostly it. This is my game, and now we can go over the project itself, and I can walk you through all the key elements of my project after this. All right, so in this section, I quickly want to talk about how my project is set up, all the different things it has, um, give you a walkthrough about the materials that I've used and the game objects that have in place in this 3D scene, some lighting experiments that I've done in this game, and also go over post processing really quickly. Okay, so let me come out of this game window. Mm, yeah. Um, Okay, so this is what my project assets folder looks like. I have some animations, animators, icons, which is mostly my sprite files that I learned to use in this game, which was pretty cool. And then inputs that I can talk about in the next few sections, I guess. Materials, I have a lot of prefabs from different assets that I got from Unity Asset Store. There's something that I learned to do in this game from some tutorials was keeping my logic separate than my visuals. So if I have a player and I should have the visual separate, so make all the visual changes separately, and then my logic stays on the main player, which I thought was a neat trick. So I tried to follow that wherever I could. My readme file, my scenes, scriptable objects is another thing that I learned to use in this game, was I thought was pretty cool how I can sort of like reuse certain things instead of hard coding, that I can talk about separately again, my scripts and my textures. So I can quickly show you what all game objects and materials I have in my game. Let me maximize this window. Okay, so this is sort of what my 3D game scene looks like. I thought I did a good job of capturing the feel of the game. So this is like a kitchen that you would find in a dungeon setting, I guess, and it has like a lot of different spooky elements outside of it. So it has like a dinner table, all of these forest elements, has trees, grass, weed that you can sort of see on the side. Um, some monsters, and then a lot of like different kitchen objects that I have here. A lot of decorations for different things. Um, and these are my counters on the kitchen scene. Yeah, so these are all the materials that I have. I don't think I need to go in detail about any of these. I've mostly just downloaded these materials from the Unity Asset Store and sort of like try to understand how it will look good in this setting. So I try to recreate the scene on my own and placed all of these separate objects one by one on here in the scene. But yeah, that's mostly it for my materials. Moving on quickly with the lighting, I removed the default skybox that we have because I thought that was too bright. So if I go under lighting here, I removed the default skybox, added like my own skybox material, sort of like give it like a nighttime feel to it, and have hard shadows on coming from all of these objects which are kept outside of this game, this kitchen window. And apart from that, I basically wanted the outside to have like a nighttime feel to it, but I also wanted that the player should be able to see the kitchen in a bright light because, of course, the main action would be happening inside the kitchen. So I added a spotlight on top of the kitchen so that even though everything else outside this kitchen is dark, but then this kitchen is still like a bit brightly lit, I guess. Yeah. And then apart from those main two changes, I also tried playing around with these a lot of point lights basically. So I have these four torches on the side and I added like point lights to it. All these dinner tables that you see on the outside also have a lot of point lights attached to it. I thought that it really helped enhance the visual quality of the game and just like added on to the overall feel to the game, I guess. So if I go into it, this is my torch, and then my torch has a point light. One thing that I quickly want to point out that I learned from this game was basically, let me show you. Yeah. So I learned that there's a difference between real time lighting and baked lighting, sorry. So if I go under my light option here under my point light, I basically changed all of my static lights to the mode baked because I learned that it's better to use baked lighting for static objects since it sort of like reduces the burden of the game performance, and it sort of pre-computes the lighting information on its own and it doesn't really rely on direct lighting, which I thought made sense for all of these point lights that I have. So yeah, these are all baked lighting that I added and sort of like played around with the range, mode, intensity, and everything. And I think, yeah, it added a good feel to the game overall. So that's my materials, my lighting. Quickly want to talk about post processing as well. I initially had read that if you build your project in URP, you have like a lot of good lighting options and post processing things in it. That was the main reason why I wanted to build my game in URP pipeline. But then I had a very hard time actually finding assets which were compatible with that mode. So I came back to the built-in vendor pipeline and sort of like build my game on that. But I did manage to learn how you can actually add post processing in these kind of pipelines as well. So basically, I installed a post processing package from Package Manager. Yeah, I installed it from here. And what it does is it allows me to add a post processing volume to my game. So I added a empty object here. I attached a post process volume component here on top of that, and I added all of my effects, different kind of effects that I learned from YouTube tutorials, and I added them here. Played around with the settings of different options. So I have these bloom effect, a lot of like color grading, playing around with saturation and contrast, vignette effect. So um, some more playing around with intensity and smoothness, and I define all of my post processing volume here. Then I made sure to attach it with my main camera because that is what actually will apply it over my game. So I changed this empty object that I made called post processing volume into a layer from here, defined it as post processing. And I went into my camera and added, where's my main camera? Yeah, here. On my main camera, I added a post processing layer, and the game object that I had defined previously, I added it here in the layer post processing, and which sort of like applied the entire post processing on my game. So if I can quickly show you a difference between how the game looks with and without it. So this is with the game, with the post processing, sorry. And if I remove it, this is how it looks like. And I was just like amazed because it made such a huge difference. It just completely changed the overall vibe of my game, and I was really happy with all the changes that I was able to make with this. So yeah, that dark eerie effect that I was looking for was definitely I was able to achieve that from post processing volume. I'll definitely want to play around more with it. But yeah, that's mostly about my post processing. Yeah, and in the next section, I'll talk about my camera manipulation. So I'll see you in that next section. Okay, in this section, I want to talk about my camera manipulation and what I did with my camera and how it actually follows the player around. So if you would have noticed, there are two separate things which are happening with the camera in this game. One is there's like a slight shake to the overall camera. I'm not sure if you can see it clearly because I tried to make it very subtle. And there's another one which is the camera is sort of moving depending on where my player is moving. So I initially thought of following the same steps that we had learned in the class, but I did feel like it was a bit weird and it wasn't as smooth. And that's when I wanted to explore more about what else we can do with cameras. And I learned in the different tutorials that I looked at was something about this tool called Cinemachine, and I thought that was really cool, and I tried to implement the same thing in my game as well. So it's something that I was able to find in package manager as well, and I added that in my game. And then it sort of gives you an option to add cameras on top of your main camera. So if I go here, click on create, uh, and then yeah, it gives an option called Cinemachine, and you can have like these different kind of cameras attached on top of your main camera. What it does, it sort of like applies a Cinemachine. I'm sure like you all know about this already, but I'm just like covering my bases and explaining everything that I have to. But yeah, what I learned in the process was that it sort of like attaches a Cinemachine brain which controls your main camera, and then you can attach virtual cameras on top of it, which can have like different priorities set and have different effects. So in my game, I've added two different cameras. One is this virtual camera, which is sort of like adding a shake to the overall camera effect. If I can show you really quickly, uh, I think you can see it if I change the intensity a bit. Yeah, so I added this noise here. Um, Let me add. Hmm? Why is this not working? Da, 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 da. Okay. Yeah, you can see it here now. Wait, something is wrong, I guess, and it's not working properly. Um, okay, I can debug this later on, but the idea is basically I have two cameras. One is this one, which is adding the noise, and then on top of that, I have another camera, which is this one, which is what I'm using to follow my player around. So this has two properties: follow and look at. And yeah, if I enable it again, it will start moving. I guess my first virtual camera is not working. Okay, I'm gonna take your help for that, but then for now, yeah, my camera is so far moving and moving with the player, and I think that's about it. Okay, cool. From this section onwards, I think we can start jumping into our scripts and explore all the objects in our game window and just sort of like see how everything is working together. But before getting into complicated stuff, I think I can just like get the fun stuff out of the way. And for that, I can show you how both of my monsters in my game are actually moving around. So we have this mummy, and then we also have this bat. They're sort of like patrolling the kitchen outside, so moving from point A to point B and moving back and forth just to sort of like haunt the person who's actually cooking the food inside. And they are actually being controlled by the script called Monster Move, which is in my scripts folder here. Wait, let me just open that up really quickly. Yeah, this is what my script looks like. So basically, what's happening is it's defining two different points. So the start position of the monster and where the monster actually needs to go to, defining the target position, and we're doing that in the start function here. And then we are using a coroutine to make sure the characters actually move between those points. The reason we're doing that is because we want to make sure that the movement is as smooth as possible, sort of like making sure they're moving frame by frame. And we're also making sure that this part of the code doesn't really affect any other scripts or methods or functions outside of it. We want to be able to work on our logic separately and not worry about how those monsters are moving in my game scene. So we can do whatever and they can still keep on moving. That is sort of what I've learned from coroutines as an idea. So that's why we're using that here. And then we have this function, oops, patrol between points, and then we go in that, and then again the here the function is just checking the distance between position 1 and position 2 and sort of like making our character move towards that position. And then here we're checking again like have they reached the point yet or no. If they have, then we want to swap the position. We want them to start moving from point B to point A now, and that's why we are doing the swapping here. We also want to make sure that when they are swapping the position, when they're going to go back to the original position, we want them to rotate also slightly so that they don't just like jump into the new position and they're actually facing towards the direction that they're going to move towards. And that's why we have this function called slowly rotate. So what this does is it's actually just like making sure that the character is moving towards the target position, the newly defined target position first, moving towards that, and then moving towards that, and then the entire thing sort of like goes back and forth from there. If I can show you the movement also quickly. um, as soon as this mummy, and the same thing is happening on the bat as well, as soon as they reach point B, they're just gonna rotate first and then start moving back. So yeah, the mummy is rotating here and it's going to start moving back and then it's going to rotate again. The same thing is happening on the bat as well. So that's what the monster move script is doing. And now that we're here on these both these characters, I quickly want to show you that I've added some animations on top of these game objects as well. Again, I didn't create these animations. I got them as a part of the pack that I got from Unity Asset Store. I just made sure that I'm attaching them properly with animators and having the animation on this particular object. So both of my objects, Mummy and Monster, they both have an animator attached to it. If I can show you for one of those, Mummy has a visual called prefab visual called Money Mon, and this has the animator attached to it. All it does is basically making sure that the animation starts running as soon as we get into the code, and that's what's happening here. The same thing is with the bat as well. Yeah, and that's what my mummy move script does. And from the next section onwards, we can sort of like start talking about how my player is moving around and what's happening inside of the kitchen. See you then. So now we'll be focusing on what the player is doing and what's happening in the kitchen. In this section, I want to talk about how my player is actually moving inside of the kitchen and what are the things that I've done to actually make sure that that's happening. So for that, I have two scripts that are actually controlling the player here. So if I go inside the player, mm, here, it has a script. It has a lot of things that I showed. So we'll try to go over those things one by one. But the two main things that are actually responsible for controlling the movement part that we'll talk about for now is player script and game input script. So let me open both those up. Yeah. So this is my player script and this is my game input script. Okay, so before we actually talk about the player script, I want to talk about the game input first. How I went ahead with the game input was basically I wanted to explore a new input system that again I learned from one of the tutorials that I was following on YouTube. And you can do that by installing new input system from package manager, and then you can sort of like explore that here. If you go under your project settings in edit, you have your player, and then if I go under other settings, configuration, and it's somewhere here. Yeah, active input handling. So once I install that package on package manager, it gives me two options here. One is the input system input manager, which is the old one, which is where we are defining every single key on our own, and then the input system package, which is the new version. I went and selected both of these options because I wanted to have both of them enabled. What it does is it sort of like gives me an option to create a new game input system for my game, and I can do that by just clicking on right clicking, clicking on create, and clicking on input system input actions here. So I can click on that, and what it does is I've sort of like kept all of my inputs under this folder called inputs. And yeah, once I create that input actions asset, it opens this window for me, which I have it here already called player input actions. If I open that, I can sort of like build my own input actions on my own. So it has three columns. One has action maps, then actions, and then action properties. So action maps is what I wanna control, and then all the actions that would be attached to that one particular thing, and then what are the action properties attached to it as well. So for my player, in order to able to make it move, I define my action map as player, and then I added two different actions. For movement, I have my actions as move. The action properties for move is action type, which is value, and then control type, which is vector 2, because of course like we want to be able to read the vectors and then get the values attached to it. And then I have my key bindings here, so WASD, and arrow keys, which I can just define here, and then they all get binded together. So once I define all my input actions here, uh, Unity actually gives me an option to generate a C sharp class, so that all of the mapping that I've done in this window is sort of like defined in a script and can be handled from there. So it actually is able to generate it for me. So if I just click on generate C sharp class and click on apply, it creates a C sharp script for me, which is here, player input actions. As you can see here, it's auto generated. I didn't have to create it at all. It just generated everything, and I didn't have to change anything in this script also. I think it just like sort of like has a JSON structure, if I'm not wrong, of all the key bindings that I defined in my actions window, and it's just like defined here all over the script. So yeah, I don't think I have to get into that. What I can talk about is now how I'm actually controlling that from my game input window. So I have this script called game input, which is where all the input actions that I just defined in that asset window are getting mapped here, getting enabled here in this awake function. So this player input actions that I just showed you, it's being called on awake. So I wanted to make sure that this is getting initialized before my program is starting. That's where we're using the awake function. And yeah, it's just enabling all that action maps that we define in that window. And I can talk about this interact function separately, but for now, since we're talking about movement, once we've defined the action map, we have this function called get movement vector normalized. It's sort of like defining the input vector depending on where the player is moving. It's mapped to input actions here, so we're just constantly reading the value and doing something with it, which we'd be talking about in the player script. But yeah, all this script is doing is giving me a vector which is normalized, and by normalized I mean we're just attaching a normalized here so that we're making sure whenever the player is sort of moving diagonally, it's not going too fast, because I think there's some issue in calculations, I guess. So yeah, we're just trying to make sure we're getting a vector which is normalized here, and then we use this value in our player script, which is our main script. And honestly, a lot of things are happening here, so I'll try to break it down in different sections. Again, since we're talking about movement, I'll just talk about that. So this is my player script, and it's doing it's using this function in update, which is called perform collision detection and movement. Here we are trying to get the value from the other script, which is game input. And yeah, so we're getting game input, get movement vector normalized. We're reading the value here and then moving the player based on these values. Another thing that we are doing in the process is we're also trying to detect for collision. So we're sort of like defining a capsule around the player and making sure that it's not really hitting anything on this path when it's moving. And we're using that with this function called physics.capsulecast. This was pretty cool because when I was debugging it, it had like a feature which showed me like a red colored ray which was coming out of the player, and I could just like see where it's detecting anything and like where it's actually colliding with certain things, which I thought was cool. But yeah, this again, these are things that I learned in the YouTube tutorial, but capsule cast is something that I explored on my own, and that feature was pretty cool. So yeah, once it sort of like detects anything, if it's not detecting anything, we want it to move further. So that's what's happening here. If it's and if it's detecting anything, we of course like we don't really want it to move. So that's what's happening in perform collision detection and movement, and that's how my player is moving. Okay, another quick thing about the player movement that I can also show you is if I go in my player, which is here, again, it also has some sort of an animation. You can see it moving up and down here. Yeah, it's moving up and down, and it has an animator attached to it called GoChef. Again, I got the animation from the Unity asset store, just made sure to attach it here. One thing that I explored in the tutorial was how we can, and we've explored this in a class as well, as to how we can sort of change the animation depending on the player's action. So if my player is moving, it has one action, it has one animation. If it's standing still, it has another animation. So for that, I have my animator called Go Chef, and it has these two things. So when it's moving, it's when it's idle, it has this animation. When it's moving, it has ghost walk, separate animation. In my game, you won't really see a difference because the animations are exactly the same. But just so that I can show you that I tried to implement this, I have this functionality here. So I can switch between both these animations. I have this parameter called is walking, and then depending on if the person is actually walking or no, it can switch between these two. So my transition has these options set. So is walking true, go to ghost walk. If it's not walking, go back to ghost idle. And this is being managed by the script called player animator, which is here. Mm, here. And yeah, I'm taking this constant string, which is just taking the same value as a parameter. Again, I've just been learning that it's really bad to work with strings, so especially, and I think they call it as magic numbers or something, and you want to be able to avoid it as much as possible. So if I can just define things up before actually going into my class functions, that should technically be how I doing it. So here in player animator, this is taking my is walking. parameter from the animator, and then here we're just defining the animator component, but getting the component. And on update, so we want to make sure that we check on every frame if the player is walking or not. And we have this function which is just checking this parameter, sending it back to the animator, and it's checking if player is walking or not. So we have this one more function in my player class which is called is walking. So if I go on my player class, it's here. Where is this walking? So we have a bool which is defining is walking, which is true or false. And this is my function which tells the animator what the player is doing, is it actually walking or not. And this is also being defined in my perform collision detection and movement function. So if I go there, it's also saying if the moved here is not equal to 0 0 0, which is vector 3.0, then we want it to move. That's when it's moving. So this actually defines what is walking is doing, so true or false, and then it goes back to player animator. And then potentially I can switch between the animations in the future, but I have the base ready for that. And I think that's about it for player movement. It's being handled by player class and new game input system that I explored, and I added the player animator on top of that, and that's it. And I think from the next video onwards, I can talk about how my kitchen objects are set up, how am I interacting with, I can show you different kitchen counters and picking up food items and everything. And hopefully that should cover it. Okay. Now that we've talked about how the player is moving around the kitchen, I think we can get into the other aspects of the game mechanics and talk about how the player is actually interacting with the different game objects that are present in my kitchen. So if you see, let me play this. Yeah. If you see in my game window, there are like different types of tables here, and I'm gonna start calling them counters now because they're gonna work as different kitchen counters. So there's one type of counter which is empty, which means there's no food item or any other object kept on top of it. Then there's another kind of kitchen counter that we have, which is sort of like a container for different food items. So a player is supposed to take out a food item from here. So let's say here the player is taking a bread loaf and is able to keep it on a clear counter which has nothing on it. So these are my container counters, these are my clear counters since they had nothing on it. And in the future iterations, of course, I'll have different kinds of other counters. So for example, this one will work as my trash counter, and then we'll probably have like cutting counters and counters that the person can prepare food on. So since we have these different variations of kitchen counters that we have, I have sort of like arranged them in my prefabs. If I can just show you into my prefabs, I go on counters. I have all of these different variations of different counters here. So to start off these kitchen counters that I have my base counter, which is this prefab. If I click on that, it has nothing but a box collider in it for any kind of collision detection. And then it also has an empty game object which sort of like defines the countertop point. So if a player is keeping an object on that table, where will that object exactly be placed position wise? So that's what my base counter has. And all the other counters are like a variation, and how I've defined that is actually if I right click on here, I go on create and I click on prefab variant. So that's why these different objects are now prefab variations of the base counter. So for example, we talked about a clear counter, so we have this prefab variant. If I go inside of it, it has a clear counter visual, and it also has a selected prefab visual, which is nothing but something that's giving us the visual feedback as to if a player is going near a counter. It's, if you can see this, it's getting highlighted, right? So that's what this selected visual counter, this selected visual prefab is doing. It's similar to the clear counter visual, but it only has a different material here. So it has a material called selected matte, which is changing the color on this table. And how is changing that color is basically handled by the script called selected counter visual. And if I go into the script, here, here, yeah. And here is just selecting if a person is going near a counter, just show the selected prefab visual that we have, otherwise hide it. And it's doing that in sync with the player class that we have. So here it's like listening to this function called handle interactions. And here, if I go this function, if I go inside of it, it's sort of like sees if something is near that counter or no, and then if it is, it's sort of like changing which counter is going to get highlighted, and it's interacting with this counter visual for that. And it's attached to my visual here. This one. So it has a base counter, so it's always linked to that particular counter, and a visual object which is the same as the selected one. So if the player is getting near that particular table or the counter, this will get enabled, otherwise it will be hidden. I will run through all of these scripts because I feel like I've taken up a lot of time already, and I want to handle just the main part so that I can explain the basic logic that the game is following right now. So that's what's happening with my selected counter visuals. Now, these were about the counters that I have. Now I also have different food items, right? You see, I have a bread loaf, I have a cheese block, I have a meat patty, and my game needs to recognize these objects, which table has which particular food item, and when they take it out, we have to make sure if they are interacting with this cheese block container counter, then it's actually giving me cheese container counter, uh, giving me cheese free prefab. I'm sorry. Okay, so now we can place it here. So how it's doing that in the game is basically I explored something called scriptable object, which is again something that I learned from the tutorials that I was following. And here what it allows me to do is sort of like define the different prefabs I have. And instead of hard coding them in my code, I'm able to read a particular prefab and identify the different prefabs which are set in that. And then how it's doing that is from a class called kitchen object so, which is here. Oops, this is kitchen object. Kitchen object so here, and all I'm doing here is calling scriptable object and defining that it has a transform prefab, a sprite, and an object name so that I can identify all the different prefab food items that I have. And in my project, how it's set up is I have a folder called scriptable objects, and I can just create all of my scriptable objects within that. So if I go inside this folder, if I click on create and then go to kitchen object so, it gives me an option to define a scriptable object, and that's what I've done with all of these three scriptable objects that I have. So for example, this is my bread loaf scriptable object, and it has the same things that I had defined in my class. So it has prefab, which is attached to my bread loaf prefab. Then it has a sprite that I created separately. So these are my sprites, my 2D images that go on top of that table, and then also an object name so that I can recognize that particular prefab. So this is how it's interacting, and then I also need to make sure that if I'm attaching these scriptable objects to my actual prefab or not. So if I go within my prefab, I go here, I click on bread loaf, and yeah, this scriptable object that I have is attached to this particular prefab. And how it's doing that, it's doing that via the kitchen object script that I have, which is here. Here. Yeah, so it's defining a kitchen object here, and then it's defining all the methods for handling different sort of like kitchen objects that I have in my game. And before I explain that, I'm making use of an interface which I've defined in a separate class, which is kitchen object parent, which is here. And all here, yeah, and all this is doing is basically it's defining the different methods that are required for managing all of these kitchen objects. And any class that implements this interface, so for example, if a player class is implementing it or a counter class is implementing it, it needs to define that how it's actually handling all of these different kitchen objects if it's interacting with any sort of food item in my game. So set kitchen object is basically assigning an object to the parent. Get one is retrieving a current object, and then clear kitchen object is removing an object from the parent. So how I'm interacting with the different tables and sort of like picking things from one table and keeping it on another table, it's sort of like being handled by these interfaces. And any class that needs to do that must implement this particular interface. So going back to the kitchen object SO, this I've showed you already how it's sort of like identifying the different food items I have in my game. And then we have kitchen object script, which is basically defining all the objects which are attached to different parents, and it is using the interface here. So kitchen object I kitchen object parent here. And this is all it's doing is basically trying to manage the transfer of objects between players and counters. So for example, if a player picks up an object, then that object's parent becomes the player, and that's how the food item sort of like travels between the player and the tables. If the player keeps the object on another table, then the object becomes that counter or the table instead. So that's what's happening in kitchen object, which is attached to all of my prefabs as well here. I hope that's clear. Um, Apart from that, I have counters as well that I talked about. So I have clear counter, I have base counter, I have container counter. So quickly, if I want to run through those, these are all defined in my different scripts. So again, moving back to my base counter, which is here. So this serves as the base class for all the counters that I have in my game. It's basically providing a common functionality, like managing kitchen objects through kitchen object parent interface that I showed earlier. So all the methods are actually here defined as proper functions. So getting the kitchen object, setting the kitchen object, clearing the kitchen object, and if you want to see who has the kitchen object, yes or no, not who, but like if a certain game object has a particular kitchen object attached to it or no, yes or no, that comes from here. And as you can see, this base counter is actually implementing this interface as well. So it's defining all the methods which were stated in that interface earlier. And yeah, and then we have the other two variants, which are clear counter and container counters. So if I go into my clear counter, all it's doing is it's allowing the player to place or retrieve objects from a particular table. So if a table is empty, the player can keep the object there. So this is what the logic is saying here. So we have this interaction. And yeah, if the kitchen object is not there, and if the player is carrying something, keep it there. If it's not carrying something, then don't keep it there. That's the logic here. And then we have a container counter script, which is here. And all it's doing is, again, it's spawning new kitchen objects using the kitchen object SO that we had. So it's reading that, and it's just generating items like tomato. Let's say if there's a tomato table in the future, or for now it has like a meat patty or like a cheese block. So it's just spawning those items here within this script. What else do I have to explain? All of these interactions are also tied with player. So if you remember, I had shown you in my game input here. Yeah. So I talked about the move action that I had defined earlier. I've also defined an action called interact, and this has the key binding as E. So basically, whenever a person is pressing the key E, that means that player is trying to interact with a certain game object, and that's what we need to be looking out for in the player script. So here, if you see in my start, the player is I'm always listening about any kind of like event presses that are happening, and then there are different events attached to it depending on which function is getting called. So in the handle interactions, we are defining which counter is getting selected, and then we are selecting that and showing that. And yeah, since this player class is also implementing the iKitchen object parent interface that we had defined, so that's why it has all these methods of setting and getting and clearing the kitchen objects here in the player class. And Yeah, that's about it. If you want me to go deeper into the scripts, I can. I just feel like it was a lot on its own. So I'm gonna end it here. And yeah, I think, I hope I'm able to give you a brief overview about my game so far. And let me know if you have any questions. This has been a lot of fun, and I definitely feel like I learned a lot. And in my creative project too, I'm definitely going to be trying to complete this entire workbook level, and hopefully by the end of this course, I'll be able to show you a fully functioning Undersold game. Thank you.